Hey everybody, this is Mr. Chernetsky, and this is Unit 6, Lesson 3. Title is Pied, because we're going to be talking about pies, or more specifically, slices of pie. Okay, so to start here, we are going to take a look at some vocab words that you may or may not have heard of, and we're going to basically define them by drawing them on a circle that's kind of been sliced and diced with this hexagon in. So the first one we're going to look at is the word sector. And a sector is essentially like a slice of pie or a slice of pizza. It's a wedge of a circle. Basically the space between two radii. So that is a sector. While an arc length is simply the length of a curved portion of the circle. So it's basically a chunk of the circumference. So those are the visual representations of what a sector and an arc length is. All right. There's another term that we use sometimes in geometry, and that is a segment of a circle. And that is the shaded region. Basically, if you connected a chord and then shaded on the in between your chord and your arc, that would give you a segment of a circle. Okay, let's go to our launch. So basically, students are celebrating Pi Day, and they are incorporating pie and pieing their favorite teachers. And basically, they've come up with a couple of options in order to make their pies. They have some round pies. They have an 8-inch round pie, and they have a 9-inch round pie, and then they have a couple of 8-by-inch square pans and a 9-by-13-inch cake pan. So I guess they want to try using some rectangular shapes, which I don't think is a pie, but I guess they're going to go for it. Okay. All right. After much debate, the club members have decided to slice the 8-inch pie into rounds of 5 equal slices, or sectors, the 9-inch round pies into 6 equal slices, the 8-by-8-inch pies, that's the square one, into 2-by-4-inch rectangles, and the 9-by-13-inch pie into 3-by-3-1/4-inch rectangles. So this is kind of hard to visualize here. So what I've done is I have sketched these 4 options here. There's our 8-inch divided into fifths, our 9-inch divided into 6, our 8-by-8 square, but then cut into 2-by-4-inch rectangles, and then our big rectangle pan, 13-by-9-inch, but cut into 3-inch by 2.5-inch rectangles. Okay, so taking a look at that, you might be able to visually guess which one you think is the biggest and which one's the smallest. But see if you can take a moment and figure out calculating the area of a slice of each of those 4 pies. And see if you can't calculate. So pause the video, see if you can calculate which one is the biggest and which one is the smallest. Okay, let's take a look. So for the 8-inch pie, rough sketch here of that slice. Okay. The area of the entire pie is equal to 16 pi. So how did I get 16 pi? Well, area of any circle is equal to pi r squared. And the radius is going to be half of those diameters. So really I plugged in 4. Go through this. Plugged in 4 squared times pi. So that's where we get our 16 pi. But we are going to divide that into fifths. So I'm going to take that 16 pi and divide it by 6. And I'll just go ahead and calculate that with a calculator, punch that in to get a decimal. And that is approximately 10.05 square inches. Okay. The next one, we have the 9-inch round. I'm not going to draw the whole circle, just the wedge for that one. Okay. The radius for that one is 4.5 times pi. So 4.5 squared is 20.25. So the area of the whole circle, the whole pie, is 20.25 pi, but we are dividing that into 6. So I'm going to go ahead and multiply that out on the calculator and see what that is. And I'm getting about 10.60 inches squared. Now, the nice thing about our rectangle cakes, those are easy to calculate the area. The yellow one here, this is just a 2 by 4 inch. So multiplying length by widths, we're going to get 8 inches squared. And then finally, our last one, the big rectangle, that's a 3 by 3.25 inch. So we'll multiply those to get that area. And we get 9.75 square inches. So we can clearly see that the yellow one is the smallest. And the biggest is going to be our 9-inch pie divided into 6. So there's our biggest one. Okay. Let's keep going and see. Now, unfortunately, not everyone in the math club is good at eyeballing equal size sectors when cutting round pies. Basically, they're saying they're not perfectly accurate, cutting it into fifths or sixths. So they might be off by a few degrees when they're cutting those angles. They're not using super precise instruments here to get that perfect cut. So if they were off by either more or less than 4 degrees, what would be the areas that we could potentially get? Like the smallest, if it was less than 4 degrees from being perfect cut, to more than 4 degrees from that perfect cut. Okay? So the first thing we got to establish on our first problem here, number 2, we're working with the 8-inch pie cut into fifths. So we got to figure out what is the perfect angle for that. Okay? So the perfect cut angle is going to be 360 degrees cut into fifths, which is going to equal 72 degrees exactly. That would be a perfect cut. Okay. So then we have two options that could be off on that. Okay, we could have as low, if we're off lower by 4 degrees, we could have a 68-inch degree on the low or small cut. Or we could have as much as 76 degrees on the high cut. Okay, so those are our two extremes of where we might get our slices. So we need to figure out what is the area for those particular slices. Now, when it was cut perfectly into fifths, that was easy. You just take 360, cut into fifths, or you take the whole area, cut into fifths. Instead, we're going to cut this into an area, or sorry, a fraction that is equivalent to our angle. Okay, so we're not cutting it at 72, but what if it was 68 out of 360? Would that fraction, or that proportion, or sorry, that fraction of our area be? Well, to do that, all we're going to do is we're going to multiply that fraction times the area of that entire pie, which we already have that. We already know the area of the entire pie for the 8-inch is 16 pi. So if I take 68 divided by 360, that is going to give me my low cut area. So let's plug that into a calculator. So 68 divided by 360 times 16 pi. And I get about 9.49 inches, square inches. So a little bit less than the perfect slice. But, well, what happens if we cut it a little bit big, 76 inches? Well, same process. Instead of 68 out of 360, we're going to do 76 out of 360 and multiply that times the area of our entire pie, which is 16 pi. And we'll plug that into our calculator. And I'm getting about 10.61 square inches, so a little bit more than our perfect cut. Okay. Pause here, try number 3, but this time you're going to do the same process but on the 9-inch pie. Okay, see what a low cut area would be for a smaller cut slice and then a bigger cut slice. All right, let's check and see what you came up with. So first of all, we need to figure out what is the angle of a perfect cut on a circle cut into 6 equal slices. Well, to do that, we're going to take 360 and we're going to cut it into 6, which gives us exactly 6 degrees for the perfect cut pie. Okay, so then we'll try our low end. That's going to be 56 degrees. And we can plug that into the formula. So 56 out of 360. Multiply it times the area of the big pie, which is 20.25 pi. And we can just use our calculator to get that answer. So 56 divided by 360 times 20.25. And I get about 3.15. That does not seem right. That's because I forgot to multiply by pi. Let's try it one more time. 360 times 20.25 pi. There we go. That looks better. So on our low end, that would be approximately 9.8. 89. So really about 9.90 if I round it to 2 decimals. So there is our low possibility. Our higher possibility would be 64 degrees. So we'll go ahead and try that one. 64 out of 360 times the area of the whole pie. And we're getting approximately 11.31 square inches. Okay. All right. The student in charge of quality control finds it too difficult to measure the angle of a sector of a pie in degrees and suggests instead that they cut a piece of string that can be used to measure around the outer edge of the pie to let the servers know where to make the next cut. So essentially they're going to go around the pie using the circumference and dividing the circumference into what they needed, and then using that string to kind of mark it out. So rather than trying to gauge the angle in the middle. So in our 8-inch pie, our circumference in the 8-inch pie, just draw it here. So we know our radius is 4. Circumference is equal to 2 pi times the radius. So the whole pie is going to have a circumference of 2 times pi times 4, or 8 pi. Now we're going to take that 8 pi and we're going to divide it into 5 so that we could split, basically mark along the outer edges where to start your cut. So that's the strategy here. So we'll take 8 pi and divide it by 5, and we get about 5.03 inches. That's how far each length there. Going all the way around. And that's how you could tell how to divide it. Try that with the 9-inch pie. So pause that, see if you can do the same thing, but for the 9-inch pie. All right, let's see what we came up with. So our 9-inch pie, a little bit bigger. It's got a radius of 4.5. The circumference is going to be equal to 2 times pi times 4.5, or basically 9 pi. And then we're going to take that 9 pi, and that gets cut into 6. So we'll punch that into our calculator. And for this one, the dividing marks around, or the string that needs to divide the circle around, or the pie around, needs to be about 4.71 inches. So that's how you could mark along. Let me get that right. It's not exactly how it would be split. Or visually, look more like this. There we go. 4.7, and then another 4.7, and then another 4.7, and so forth, all the way around. Okay. We have a friend here, Wendell, really likes pie, and he's gonna get exactly how much pie he wants, how much area of pie he wants. And he wants exactly, or at least I should say, 15 square inches of pie. So the question is, if we're working with the 8-inch pie, what is the small sector of the 8-inch round pie that will satisfy Wendell's cravings? Let's draw our pie here, okay? And what we're trying to find, because we're not dividing into fifths, we're trying to figure out what is this angle. Call that N. What is that angle in degrees that's going to guarantee to give us 15 square inches of pie? So we're going to set it up just the same way we've been doing with our angle over 360. The difference is we don't know what that angle is. So we'll just put that in there. Okay. We're still going to multiply it by the area of the entire pie, which, if you remember, the area of our entire pie was 16 pi. And we know all of that has to come out to be 15 square inches. So really we're working backwards. We are going to solve, in fact, I'm going to change the color. Let's make that red there. So we are trying to find n, basically trying to get n by itself. So a couple things we got to get rid of. We got to get rid of that 360, and then we got to get rid of that 16 pi. So the first thing I'm going to do to get rid of the 360 is let's multiply both sides of our equation by 360. Those cancel out. And so what we have now is 16 pi is equal to 5,400. Oops, I forgot the n. So n times 16 pi is equal to 5,400. So now to get rid of the 16 pi, we're going to divide both sides by 16 pi. Now be careful when you are dividing on your calculator by 16 pi, make sure you put parentheses around that, because your calculator doesn't know, or your calculator will be confused and think, oh, you mean divide by 16 and then multiply by pi, and you'll get an answer that is not correct. So put parentheses around your denominator. If you have multiple things in your denominator, it's a good idea to put parentheses around it. So we do that, and divide by 16 pi, we get an angle that is approximately equal to 107.4 degrees. Okay. All right. Question 7. How long should the string be to measure the outer arc of the sector? Okay, well, now we have an angle out of 360. And that is the fraction of our circle. We're going to multiply that by the circumference of the entire pi. Why circumference? Because we're trying to find, in number 7, we're trying to find that distance. Okay? So we need that fraction, that 107 out of 360 times the whole circumference. Well, the whole circumference, if you remember, is 8 pi. So times 8 pi, that should give us the length of the string along that outer edge. This is not going to divide our pi evenly, right? We're just trying to get this one big slice for our friend Wendell. So let's go ahead and try that. 107.4 by 360 all times 8 pi. And we're getting approximately 7.497, so really about 7.50 inches. That's how long our string needs to be along that arc. Okay. Why don't you pause? Try number 8. We're going to do the same thing, but we're going to be working on the 9-inch pi. So see if you can figure out question number 8. Okay, let's see how this works out. So again, we don't know the angle. Let's draw our picture here. We have our bigger pi now. So our bigger slice. We don't know. Oops. We don't know that angle. So we're going to take that angle out of 360 and multiply it times the area of the whole pi. So our area for the bigger pi, we scroll back up, is 20.25. 20.25 pi. Don't forget the pi in your pi. And that is going to equal, remember he wants a 15, guaranteed 15 square inch area slice. And solving it's basically the same process. We're going to multiply both sides by 360 to get rid of that denominator. So then we have n times 20.25 pi equal to 5,400. And we'll divide both sides by 20.25 pi. Make sure you put parentheses around that in your calculator. And this time our angle is approximately equal to 84.88. We'll just go one degree. 84.89 degrees. Okay. So smaller angle than on the smaller pi, and that kind of makes sense because we have a bigger pi, so we don't need to make as wide of a cut to get Wendell his 15 square inches of pi. Okay, a couple more questions here to try. Try number 9. Now that we know what the angle is, figure out what is that string going to have to be along the outer arc. Here, what is that outer arc string need to be, that arc length? Okay, well, we know our angle is 84.9 out of 360. And we're going to multiply that fraction times the circumference, because remember we're dealing with how much around, the fraction of going around, not area. So the circumference of our 9-inch pi is 9 pi. So we're going to take that fraction, multiply times 9 pi, and that should give us that string length. And I'm getting approximately 6.67 inches. And again, that makes sense. It's a smaller arc length because we don't need to take that big a chunk out of the bigger pie to get that area. Okay. Number 10 is just more of a general question. What if we didn't know what the angle is? We just want a general formula to find an area of a slice of sector out of the 9-inch pie, and what is the arc length. So if we were just cutting different angles and we just wanted to have the same formula but just plug in a number for the angle, what would that be? Well, we know that n, to get that fraction, it's always n out of 360. For the area, we're going to take the n out of 360 and we're going to multiply it times the area of the entire 9-inch pie. So the area of the entire 9-inch pie was 20.25 pi. So now we can substitute in any angle for n, and we can calculate the area of any area of a slice. If I need to know the arc length of a slice, same process. That angle out of 360, but instead of multiplying by the entire area, we're going to multiply by the entire circumference, which was 9 pi. And now we could figure out anything on any slice on the 9-inch pie. Now, in a moment, we're going to make this even more general. We're going to make sure that we can find the area of a slice of any size pie, or the arc length of any sliced pie. So let's go through and take a look at that. So arc length, we still need to have that general n over 360. But instead of multiplying it times 9 pi, that was very specific to the the 9-inch pie, so we want to make sure that we make it more general. So we're really multiplying by the circumference. So the circumference of any circle is just 2 pi r. So that's what we're going to do instead. Now all we have to do, we can find any arc length simply by knowing the angle of that slice and knowing the radius and having a calculator handy. An area of a sector, very similar. N over 360, but instead of multiplying by a specific area of a specific pi, let's just make it more general and multiply it by the area of any circle. So now we can find the area of any sector, any pie, any pizza, any round shape that we want. Okay. Here are some definitions that you can more specifically write down. We have the pictures up at the top, so we already saw them as the shaded parts of those pictures at the top, but here is the definition in words. And that is it. That is all I have for you today.